All right, so we were in the process of our review. I'm hoping that we can finish this up today. So we were discussing last time, review of polymorphism. We kind of rushed through this dynamic at the very end, so I wanted to take just a little bit more time and talk about it in just a little bit more detail. So we talked about compile time polymorphism, and that's when we're analyzing the program before running the program. We know what kind of polymorphism it is, and that's the case if we have method overloads. Sometimes we don't know until runtime, and that's when we are declaring variables of either a subclass or a superclass type, and then setting them to be either the subclass or the superclass type. So there were three different ways for that dynamic polymorphism. You could either reference a superclass as a superclass, a subclass as a subclass, or a subclass as a superclass. I think we have experience with that, so I probably don't need to go into too much detail there. Let me know if that's wrong, and we can circle back to it and come up with some good examples of that, if that would be useful for the class. There we go. But after finishing up the polymorphism talk, how do we feel about polymorphism? I noticed that I'm seeing probably about 50 to 60% of the class participating with their thumbs. Those of you who are doing it, great. I appreciate it. For those of you who aren't, note that I have no idea where you are or how things are going for you. And admitting that you don't know something is perfectly okay. Even if everybody else around you has your thumbs up, that single thumbs down gives me a very important piece of information. And even if I don't want to spend a significant portion of class going over this, I can say things like, if you gave me a thumbs down, come see me during office hours. Let me help you get caught up. I really do need to see that from the class, because if there are elements of this review that I don't circle back to and you don't have a good understanding of, you're going to start this class being behind, and it's going to be torturous for you and for me, because I want to see you be successful. So if that's the case at all, please let me know. Come talk to me after class if you don't want to display the thumb publicly. But make sure that you let me know, and I can help you get caught up. All right, the next thing we want to talk about is composition. So composition has a relationship. When you have a class and one of the fields in that class is a member of another class, it has a member of it that is some other object. So as part of its state, it can have other objects. This is a way to break down more abstract objects into smaller and smaller pieces until eventually we get all the way down to primitive variables. And that's the nature of object-oriented programming, is we're just going to abstract groups of these primitive variables and give them labels, and then make groups of these groups of primitives and other groups of primitives and give them more abstract names. And we build, kind of using these puzzle pieces, we build more complex objects out of it. At least that's how I view object-oriented programming. So composition is just the concept of breaking down a more abstract thing into either still more abstract, but slightly more concrete components as we get closer and closer to just integers, doubles, characters, things that are primitive. Often in design, we have a choice between composition and inheritance. We can choose a has a relationship, or we can choose an is a relationship. All things equal, what should we choose? Which one of these is going to be a better design decision, leading to more easier extension, or the ability for this code to be easier to edit, basically? Less work in the long run. What would you choose?
Inheritance.
Inheritance? Who agrees? Inheritance is probably the better choice. Who thinks composition is probably the better choice? Interesting. So we have probably about 40% of the class raise their hands for inheritance, and nobody raised their hands for composition. As we will see throughout this course, the answer is actually composition. Inheritance is very powerful, but it also has a number of large red flags. And we're going to start to see as we introduce these concepts of design patterns, some of the design flaws that you can make, you end up making decisions that lead to, it might work exactly for the problem as specified today, but as the requirements of your large scale program evolve over time, you will find that you find yourself pigeonholed into decisions that require lots of work in order to make it continue to work as your requirements evolve over time. You never know for sure exactly what you're going to be making on day one in a large project. We'll talk about this a lot. If you take software engineering from me, I'll be offering it both next fall and next spring. But that is a very big part of the beginning of software engineering, is trying to figure out, all right, how do you even communicate with a client who has no technical background whatsoever? They're communicating things to you. You're trying to figure out, okay, what is it that you want me to do? How do I build a technical solution to your non-technical problem that you're communicating to me? And there's always going to be back and forth as that communication becomes clearer, as you show things to them and they say, that's not what I wanted this and not that. And you go, oh, you should have told me that in the first place, but they didn't. So you have to go modify what you had produced to show them to make sure that it starts to align with what they want out of your program. So this kind of work will become very important as you start doing things and designing solutions for people who are not you. So let's talk about some of these principles. We'll come back to these principles as we encounter them, as we start showing design patterns, going over some of these design patterns. But these are the general principles that will come up over and over again as we explore this. First, we want to encapsulate what varies. If things change between objects, we can encapsulate it. Favor composition over inheritance. If you have solutions that work equally well with composition and with inheritance, we will find time and time again that composition leads to less future work than inheritance. That's saying all things equal. There are definitely times where inheritance makes sense over composition, but usually that's because inheritance allows you to do something that you could not have done with composition. We want to program to an interface, not a particular implementation. We'll figure out and see some design patterns that adhere to that, and we can see the benefits as we see that. We want loosely coupled designs between objects that interact. If we have tight coupling, any change to one will affect the other. So we want to be able to loosen that coupling so that we can change something in one object and we don't have to go back and modify the other object as well. And we'll see some design decisions that allow us to do that as we start exploring it. Classes should be open for extension, but closed for modification. So once we have an object, we don't want to change things about that object. We want to add additional functionality without modifying the existing functionality. If you want to modify the existing functionality, usually you want to make a new object. We also want to depend on abstractions. If we have concrete classes, that's going to lead us to need to be very specific with things, and it's not going to be very modular. If we abstract as much of that as possible, then the work that we do when we decide that it needs to do something else, we'll be able to do that a little bit easier. And of course, only talk to your friends. Objects should only be interacting with other objects that are in the same package and communicating. You should not have a massive hierarchy of communication between a bunch of different objects that do a bunch of different things. We have don't call us, we'll call you. An object shouldn't be taking in a bunch of requests from other objects. Usually, the object's goal will be to communicate what it needs to communicate to others and not the other way around. And finally, a class should only have one reason to change. And we'll see all of these with some different patterns, and it will become a little bit more clear as to why these are good principles to follow in your program's design. So I just wanted to throw that list out there. This isn't really part of review necessarily. Maybe you've seen some of these before, maybe you haven't, but we will be coming back to them as we encounter them. Clonable, back to a review topic. What is clonable and what does that mean with regards to an object? Yeah.
Would it be instantiating multiple versions of the same object?
Multiple versions of the same object? Somewhat. It's a good place to start. So clonable tells us that we can make copies of a particular object and then pass around those kinds of copies. So the reason we might want to do this is, I can think of many reasons, but some of them are things like you have an object and you need a copy of it for modification, but you don't want to modify the original, you want to modify the copy. So there are two different kinds of copies in programming. We call them shallow copying and deep copying. Have we heard these terms before? Let's actually draw a couple of memory diagrams because this is a very important concept when it comes to implementing clonable, which is an interface, and if you're thinking about producing your own objects and what you want to do for them. So let's say we have an object. I will make some kind of array just because it's a very simple object that can do a bunch of different things. So here is some object. We'll call this, I don't know, what do we want to call it? List. If we somewhere in our code say, let's say this is of some type array list. This just says array list, list 2 equals list. What have we done here? Any guesses?
Made list 2 equal to the contents of list 1. Size, whatever's inside of it.
So I've actually lied a little bit when I do this. This is a more appropriate memory diagram for how list exists. What we get is a reference to this area in memory. This lives in the stack, this lives in the heap. This is where your data is, and when you refer to what list is, it's going to follow this that says the list is stored here. When you refer to anything with regards to list, it's going to refer to the data that's involved. When you set equality like this, you're really doing this. It's a second reference to the same storage. Now, if what you were to do were to say something like list of 0 equals 6, let's assume that they're all default values, they're integers. They have zeros, which is the default value for integers. And I said list of 0 equals 6. That's modifying the data that's stored in the heap to turn this into a 6. If we were to query what is list 2 of 0, we would see that in fact, the result is 6. So by modifying list, we are unintentionally also modifying list 2. So this is what we call a shallow copy. We're not actually copying the object itself, we're just making another reference, kind of giving it another name. It's similar to how I can be called Chris or I can be called Dr. Kane. I don't really have a preference between them, but there's only one copy of me. Depending on the name that you use, you're still referring to the same individual. And this gets into, I like really memorable examples that aren't super appropriate for some reason. But if you get really mad at me and decide to punch me in the face, if you were to query, is Chris injured? The answer would be yes. Is Dr. Kane injured? The answer is yes. You don't have to throw 2 punches to injure me. You only need to throw 1 to injure both names. It's kind of a memorable example. I don't know why I resort to violence in them, but it's memorable. So the same thing is going on here where you have two different names for the same underlying object. If you modify one of them, you're modifying the other one as well. Does that make sense? Are there any questions about that? Why do you think something like a shallow copy exists? Why would we ever want to do that? What happens when you pass a large structure like this to another method? You've experienced this before where you have something like you pass an array or an array list to a method? What happens if you modify that in that method? Do you need to return that value, or is it just, does it change? Anyone ever experienced that? So we have some main scope. Somewhere in there, you make an array list. And of course, this needs a type. Probably should be using the wrapper class. And then you do some things to that, and then you want to call collections.sort, and you pass it that list. Notice how we're not doing anything like saying list equals collections.sort. We're not storing anything coming back from collections.sort. This, in fact, would be wrong. You just need to say collections.sort and pass it the list. The reason is this list is being passed by reference to collections.sort to be sorted. So it's getting a second name for it, the name that's in the scope of collections.sort. It's going to sort the list, and then it does not need to be returned to the main scope because it's modifying both at the same time. This is good because we don't have to copy this entire object. This is an array of size 5. What if we had an array of size 1 million? Or 5 million? Or they weren't integers, they were really complex objects. It would take a very long time to copy that object all the way over, make the change, and then copy it all the way back. That's completely unnecessary in this scope. So we can do the same thing by just passing a reference to it. And that allows us the ability to modify an object without fully copying it. Question?
Why would you want two different names for the same reference?
If you're going to make an API like collections.sort, you're going to name a parameter, right? You're going to write a method, and you need to know what the name of that thing is. You don't want to force whoever's calling collections.sort to name their collection a particular thing. So we're going to have multiple different names that refer to the same object. If you were to write your own sort method, it takes, I guess we would have something like it's going to be off the board for people, I apologize. So something like this. We're going to write this sort functionality. We don't want to force the person who's going to be calling this sort function to name their variable something. We would have to, in addition to saying, this is how you use collections.sort, you pass it a list, you'd have to say something like, the variable that you pass has to have this particular name. Otherwise, this won't work. That's having the person who's writing this code who just wants to sort that without writing the code to sort it, to name their variables using a particular method that they may not like. And it requires them to look up something in order to be able to use this functionality. that make sense? That's a great question. So this is the concept of a shallow copy. We use it all the time to just pass things. When we don't need a second copy of it, there's no reason to go through the process of going through and copying every single value. On the other hand, a deep copy does go through and copy every single element of the object. So now we have I made one more than I did last time. If we're going to do a deep copy, then we would have some other name that points to some other object, where if we're going to make this object, then we need to call its constructor and then go through a loop that's going to say whatever is here goes here, whatever's here goes here, whatever's here goes here. That's a lot more work than a shallow copy. But why might we want to do a deep copy of something?
You might want an unsorted list and a sorted list.
Yeah, you might want an original and a modified version. You might want, there are tons of reasons why we might actually want a copy so that we can freely carve this up and do something without modifying the original. So there are two different kinds of copies. So clonable is an interface in Java that allows us to write a clone function that will make a field for field copy of that class. So we have some class instantiation and it allows us to clone every single field of that object. So is that a shallow copy or is that a deep copy? If we're copying everything over, that's going to be a deep copy. So why might we want this functionality? Lots of different reasons. But if we're going to implement clonable, then we need to override the clone method. And that specifies, okay, how does this copying work? The default is going to be a deep copy, or I actually don't know. I have to look that up. But there is a default, you override it and you specify, here's exactly how the copying procedure works. And you can override it with a shallow copy, a deep copy, or anything in between, where some components are shallow copied and some components are deep copied. If you had an object where it had some fields that were 4 integers and a really big object, maybe you want the really big object to be shallow copied and everything else to be deep copied. But you have full creative control again about how this object is copied. There is no default. So yeah, failing to implement it results in whatever the default behavior for that kind of object happens to be. So for instance, a string or another object's default is a shallow copy. So if you want a deep copy, then you have to specify within clonable, okay, now give me a deep copy and go through the work. The reason it's the default is, by default, we want to do the least possible work. If you want more work than that and have a reason for that, then you need to specify that in the clone function. Questions about clonable, implementing clonable, and what that looks like. I think the really important thing here is the shallow copy versus the deep copy. Having an understanding of that will at least allow you, if something happens, hey, I modified this object and it happened to modify this other object. Why in the world did that happen? You'll know that they're both pointing to the same data. There was a shallow copy somewhere where you probably meant to have a deep copy. All right, next we have exceptions. Who has seen an exception before? Who's seen an unintended exception before? Should be everybody. What is an exception? Error of some kind? You can think of it as an error, but sometimes errors are intended. If you, for instance, pass the wrong thing to something, you don't want to try to deal with it. You want to go, this was not intended. And you want to have the ability to possibly recover from this error. So Java's exceptions are classes that allow you to determine, did something happen? And if so, you are allowed to write some additional code to handle what happened. So exceptions should only be thrown for exceptional or unintended behavior. If something happens that you are not expecting, you should throw an exception for it. Probably at this stage in your programming careers, you've probably only seen exceptions. Who's written an exception in their own code? A few people. We're going to be writing a lot more of them in this class because we're going to be designing more complicated things. And when we design a complicated object and process, we need to define what it means for it to be used in a way that wasn't intended. And you need to be able to recover from that unintended state if that's possible. So when the contract between the method and its caller cannot be fulfilled was a great way to think of, if that's the case, an exception should be thrown. One of these, we'll talk about preconditions in a second, but if the preconditions of this method are not met, throw an exception. If there's some fundamental assumption about the method and it's not true, then throw an exception. If you're writing an exception, you do not necessarily need to write the handling code. This could be something that can be offloaded onto the person who's using your tool. As you get deeper and deeper into computer science courses, you will find that you are less frequently solving one kind of problem, and you are more frequently writing tools that someone else is going to use. You can imagine that you are hired to write accounting software for an accounting firm. Then you're not the one who's using the code that you wrote. Someone who's not necessarily technical is going to use that. So you could throw an exception that says something happened that my code is not ready to handle. You don't necessarily have to know how to deal with that because you don't know why. You don't know what's at stake in this particular case that the exception would be thrown. But you basically communicate to whomever is going to be using this, this is what happened. And then they can write some additional code that says when this happens, if, et cetera, they can handle that on their own. But your job is just to identify when the problem occurred and to communicate that on the way back. So we have some different kinds of exceptions. There are three main classes of exceptions. The first is a checked exception. This happens at compile time. So when you click run, and before your code even begins, it just looks at your code and goes, there's a problem. Any guesses as some kinds of exceptions that you might have seen that are checked exceptions?
Could that be like a missed semicolon or something?
So that would be a syntax error. Not usually an exception thrown for a syntax error, but this is the kind that can be caught in a try-catch block. So an example of this is a file not found exception. We don't have to run the code in order to see that you're trying to open a file with a particular name in a particular directory. You can look for that before that's done, right? You can look and see, I'm trying to open a file and I have not verified, I've not allowed for a file not found exception. Have you seen that Java breaks when you do that? You need to, in a method that opens a file, you need to say throws file not found exception. Second kind is an error. This is what happens externally to your program. So an example of this is like a Stack Overflow error. Has anyone ever seen a Stack Overflow error? Or know what happens, what that is? Couple people? Anyone want to tell me what a Stack Overflow error is? Why that triggers?
I think I remember seeing a recursion. And
Yes.
there's like no blocker stop, so we just kept adding to the stack.
Yeah, so the way that we visualize this in computer science is this is the space that we have in memory for a particular program. We have a stack that's going to be building down, and we have a heap that's going to be building up. And these work together, and eventually, if you do something bad in your code, you can have what's called a stack overflow error, where there's so much in the stack that it overflows. This is what happens when you recursively call the same function in an infinite loop. Have you used recursion before, or know what recursion is? It's a function that refers to itself, calls itself, can make an instantiation of itself. So for instance, what's an example of a function that you can write recursively, that you've written recursively before? Fibonacci, sure. So Fibonacci of 10 requires a call to Fibonacci of 9, which requires a call to Fibonacci of 8, which requires a call to Fibonacci of 7, and multiple of these calls if you're starting from the top down and not storing your answer bottom up. But imagine that you implemented this incorrectly, such that Fibonacci of 10 would call Fibonacci of 10, which would call Fibonacci of 10, which would call Fibonacci of 10. And you can imagine that there's a certain amount of code. You're partway through, you write your Fibonacci function, and there's some code here, and that's all gonna go on the stack right there, and it's gonna represent, fib of 10. So partway through this code, we need to pause. We're at this line in here, and here we're gonna call itself. So we need another instantiation of Fibonacci. So we're going to make a new stack frame, and that's going to call, if we do this incorrectly, Fibonacci of 10. So it's kind of like an infinite loop, but it's infinite recursion, and it means that we're getting function after function after function after function on the stack. And if this is basically an infinite loop, eventually we're going to reach this point where we just don't have any more stack space for more functions. Your computer does not have the ability to represent more function. So you get a stack overflow error. So this is not an exception as much as it is you've utilized all of your computer's resources, and it just has to crash the program because it can't keep doing this. So this is also where all of your reference variables go, all your primitives, etc., all of your function definitions, and the objects that you instantiate with the keyword new, they all go on the heap. You'll probably explore that more in future classes. Maybe I'll explore it some more as we try to describe some more advanced OO concepts, but just gives you an idea of how these programs work a little bit underneath the hood. So another one is an out of memory error. Has anyone written a program that's gotten an out of memory error? If you just put something like make a new array list and put that in an infinite loop, you'll get an out of memory error, as eventually you'll just start making so many objects that eventually you run out of memory for it. Has anyone ever played a game that eventually crashes because it's utilizing so much memory that it crashes either the game or your computer? It happens. With advanced code and large-scale projects like that, it's very easy to introduce an accidental place where you make something and you never delete it. And then you just keep making more and more of those things. And eventually all of those need to be stored because you're not manually deleting them in a language that doesn't have garbage collection. Java's a nice language. It has a garbage collector. It manages your memory for you. But other languages like C, C++, they do not have automatic memory management. And if you do not personally delete objects that you make, they will stick around forever until your program crashes or it exits normally. Third kind of exception is a runtime exception. This means it's internal to your program and cannot possibly be recovered from. An example for this is a null pointer exception. Who has experienced a null pointer exception? Here's where I expect it to be most people. What is a null pointer exception?
You're trying to access, something that's no.
Yeah, so we used a memory diagram here where we have, some list that points to references in Java's terminology, some kind of object. Well, what happens if this object is not here? And I say, what is that list of 1? This is where a null pointer exception comes from. You have some variable that's supposed to refer to some object that either doesn't exist or has been moved to somewhere else. You cannot recover from that because you're going to assume that you have the value that's at list of 1. If we can't find the list for list of 1, we can't continue with the sequence of steps in our program. So we just have to give up and crash. Another is an array index out of bounds exception. Another one that I'm hoping everyone has experienced at some time or another who's experienced an array index out of bounds exception. If anyone has said never, you're either lying or the world's best programmer. So this is, we have some object, and again, this is list, pointing here. And so we have index 0, 1, 2, 3, 4, 5, maybe that's as big as it is. And we try to say, give me a list of 10, list of 6, list of -1. Anything that is an index that is out of bounds of the object, we can't access it. In some languages, you can. Anyone seen a language where you can access elements that are out of bounds? Yeah, you can start from the end and use negative indices in Python, absolutely. But memory like this really is just one big long sequence. Your RAM basically starts at some index and goes up to some really large index. So any object that you store, when I draw a diagram like this, there is some place where list is stored. This represents this small chunk of memory. This represents some larger chunk of memory. And this is going to store the number that represents this place in memory. So this stores that, the location of this object in memory. So if you wanted to say something like list of 10, where would list of 10 be? Out here somewhere? That memory has a value. It's still memory. What is it? Who knows? It's garbage. It might be some value in some other program. It might be something that's used by the operating system right now. It might be, you have no idea. So in some languages, you just get back garbage if you try to figure out what that is. Java is very nice and says, that's not part of this object. I'll throw an array index out of bounds exception instead. Questions about exceptions, the different classes of exceptions? You can throw any of these exceptions in your own program. And it's very useful to be able to communicate to someone that something went wrong. Next, we have GitHub. Who has used GitHub before? Quite a few people. Who has used who's used Git to interface with GitHub? A few people. That will be all of you within the next week or so. So GitHub is a very important site and tool used for code versioning, storage, and it gives you the ability really to work in large scale teams and all work on the same project, which is very useful. That's not what we'll be using it for in this class. We'll be using a combination of GitHub Actions. I don't think we'll be using GitHub Classroom quite yet, but GitHub Actions is what's going to allow you to be able to submit your code somewhere, run some tests, and get immediate feedback. So because of this, you'll need to know some very basic Git commands, which we'll go over eventually. In the meantime, though, it is important, I'll be unveiling a couple of labs, probably today or tomorrow for the next week or so, that will have you making a GitHub account if you don't have one already, getting yourself in the repository for this class, and then setting yourself up to be able to submit future labs and get feedback. So that will be coming. Watch for it on Canvas over the next day or two. Why do we think something like code versioning is important? Anyone know what code versioning means?
So you'll have version 1, which will have the basic code, and then version 2 will have all the updated code on it.
Yeah, so let's say I give you a project that is so big that it will take you between now and when you graduate to finish. Do you want to just sit down, write all of that code, and hope by the time you graduate that it runs? Maybe you get far enough in it that you realize, no, I don't want to do this, I want to do that instead. But rather than trying to figure out where in your code you need to go delete code, maybe you break some functionality that you didn't intend as you do that, and you end up with this massive spaghetti project that doesn't do anything, and you have no idea why it's not working. So code versioning allows you to make save points in your code whenever you make any change, really. And it helps you to be able to go back if you make mistakes. It helps you to be able to branch from code, and you make some changes, but it doesn't affect what someone else is doing with your code. And you can work in tandem on different things and then merge your work back together in ways that you can both work on the same code at the same time without getting the minute-to-minute updates of whatever your partner is doing that's breaking your code. So GitHub is extremely good for this. And again, for those of you who are going on to something like software engineering, you'll be doing this significantly in group projects, and you'll become a GitHub expert by the end of that class. So it allows multiple programmers to work on different parts of the same files at the same time. So significantly more features will be discussed in future classes, but for now, all you really need to be able to do is commit your code. So you'll need to know commands like git add, git push, git pull, and we'll go over all of that as we get closer to needing to do that. So for this class, you'll be submitting your labs to GitHub. First lab will get you set up and be able to submit future labs. I'm sure you will have questions about GitHub, but I'll address those as you start getting prepared for that. JUnit. Does anyone know what JUnit is? Used it before? 2 or 3 people? That is the very next topic in this class. We're going to become very familiar with JUnit, but testing is incredibly important to programming. So JUnit is a tool, a Java-specific tool, useful for writing and running custom unit tests within Java. A unit test is a test of some small piece or unit of your code. And you're going to give it a very specific example. And then you're going to determine if your code is using this particular example, there should be an expected output. So this is going to run your program with that input and check and see if the output is what you expect. If it is, then your test will pass. If it does not, then your test will fail. With an intelligent use of testing, you can eliminate a significant number of bugs from your program and know if you introduce a change that causes some functionality that you thought was working to stop working. Anyone manually run their code a bunch of times to test it and make sure it works? It's a huge waste of time. In a large-scale project, you don't want to have to do that 100 times every time you make any change to your code. And in fact, we have, and we'll go over this in 350, but I'll give you the idea now. There's this concept of continuous integration that whenever you push code to GitHub, an external repository, you will have every test you have ever written for all of your code And instead of allowing that code to just merge with your existing code base, it will run all of the tests you've ever written. If any one of those tests fail, merge will fail, and you will not mess up your existing working code. If all of the tests pass that you've written, then it will allow you to merge your code. And then you just continue to write more tests as you get more functionality, and you know that, at least according to the best of your knowledge, that your code is always working. That's very important for large-scale projects with lots of people on them, because who knows how good your partners are, who knows if they're introducing bugs, but you can write tests that ensure that what they're doing is not breaking your project. Very useful, saves a ton of time, and it squashes a ton of bugs, which is very useful. Does it get all of them? Of course not. But we'll go over what intelligent test writing looks like, how to think about testing, and that'll be a next week topic. So we will collect a suite of test cases in some separate test files, and we will run them all at the same time, determining, is your program functioning as it should to the best of your knowledge? It allows you to see the results of all the tests at once, so you don't have to run your program, enter 1, run your program, enter 5, run your program, enter -1, run your program. As we get into testing, I'll have quite a few fun computer science memes with regards to testing, because there are a lot of good ones out there, and they're very funny. So, saves a lot of time. One thing we will talk about also is test-driven development, which means that in order to test your code at all, you don't even necessarily have to have it written yet. You can start writing what you expect the output of your code to be before you write a single line of code. And then as you write your code, you can watch your tests start to pass as you implement something that passes the tests that you wrote before. And this allows you to not get too deep into your code and make sure that it's working feature by feature, again, as you're doing large-scale projects. So that's called test-driven development. We'll have an entire unit later this quarter on test-driven development. Some generic examples. With this particular input, after I run this method, it should return 3. You could write a test that specifies that English logic. After this code runs, these 2 variables should have the same value. After we sort the list, it should contain the same number of elements as before we sorted the list. Sometimes they're very basic ideas, but they're gut checks of, did I royally screw this up somehow? Sometimes your tests will alert you that something like that has happened. And they're very easy to write. Enums, who's seen or used an enum before? Yes, good. That's what I like to hear. So enums, a set of constant final values that are defined together for some purpose. This could be something like all of the months of the year. They're a collection that can be used together, and if I wanted to set a month of the year to some value that wasn't January through December, an enum would not allow me to do it. So here's an example, pizza status. Someone submits an order for a pizza. It can either be ordered, or once it's ready to be delivered, it is ready, or it is delivered once it has been dropped off. And note that if you were running a pizza store, the same people don't necessarily have access to all of that information. So you could write an app that allowed people to see, maybe the customer wants to know whether or not their order was received, whether or not the pizza's done and on its way, or whether it was delivered to the wrong address. From the delivery driver, should they go pick it up because it's ready? And once it's delivered, does it successfully say that it's delivered? From the pizza maker's perspective, was there an issue with delivery that might cause you to need to start prepping the next one as soon as possible? So an enum allows you to very easily within your code see that these values have particular meanings. Now, these enums underneath the hood are just integers. And you don't necessarily have to program with an enum. Whenever ordered, you could just replace that with a 0. Ready, you could replace that with a 1. Delivered, you could replace that with a 2. But how readable is your code if you're using 0s and 1s and 2s to represent these things? How easy is it going to be for you to find bugs? really hard. So enums are really a readability thing that help put as much English into your program as you reasonably can. We're unfortunately out of time. That's going to be it for today. Keep an eye on Canvas. There will be some labs for you, a couple labs for you to do over the next week. Don't know exactly when those are going to get out, but hopefully today or tomorrow. And we'll continue through this last day of review tomorrow.
I remember. That's crazy. Were we in the same meeting class?
Yeah, like every class. Most of which
I think it was the second Java class that we had. I believe.
I couldn't say.